This short video will demonstrate how to make structural measurements on three-dimensional virtual geological models utilizing GeoVis3D. The first class of measurements that are appropriate are to measure the planar external surfaces of the model. If we zoom up on this model from Harvey's Reward on Kangaroo Island in South Australia, you can see that there are clearly a number of well-defined bedding planes, and we can directly measure the orientation of these surface features using a number of mechanisms within GeoVis3D. On the bottom left hand corner you'll find the sample mode button. Clicking on this you'll see there are a number of different sample modes, and the first three of these are directly relevant to measuring planar aspects of the surface of the model. In point mode, the orientation of the surface of the model is determined based upon the orientation of the triangular facet in which you click the cursor. In multiple mode, nine adjoining triangles are sampled, and the vector mean of those 9 adjoining triangles is specified as the orientation of the planar facet. In the neighbour mode, the orientation at a node in the network is calculated, and the vector mean of that node and all adjoining nodes is calculated as a means of specifying the orientation of the surface. In general, these three methods for specifying the orientation of the surface produce very similar results on well-behaved surfaces, and only diverge significantly where there is significant noise or if a measurement is attempted on an asperity in the model. So for our first set of measurements, we'll set the mode to be point. The next thing is to specify what feature class should be digitized. The list of possible feature classes is listed in this list, and in this particular case the feature we wish to digitize is bedding, so we'll designate it as S0. So now, in order to make a measurement on the surface of the model, it is as simple as pointing at the facet of the surface of the model you wish to measure, and holding down the Shift key and pressing the left mouse button to digitize a location. Alternatively, if you go to a location, double-clicking on that location also has the same effect. When you've digitized these points, it sometimes is helpful to zoom in and just check that the points appear to conform well with the orientation of the digital representation of the surface, which in this case both of those points do. You will have noticed that on the right hand side in the StereoNet pane that as points are added, they are automatically plotted as poles on the StereoNet plane. Let's add a few more points to illustrate this process. So I'll add them in this current viewport, and we might sample one on the overturned limb of this particular fold. So now what we can see is a series of points plotted on the StereoNet. It's important to note that in GeoVis3D each of these points is hot linked, such that if I click on a point in the data table, it automatically highlights that point in the StereoNet and repositions the model such that that point occupies the center portion of the model space. Alternatively, if I click on a point in the model space, it also highlights it in both the data table and in the StereoNet. In addition to that, you'll notice that each of the points in the data table and in the StereoNet can be toggled on or off, and we can also elect to display those planes as poles, which is the default option, or alternatively to display any individual planar feature as a great circle rather than a pole. We can toggle the display of all features utilizing the button at the bottom of the screen. So we'll toggle back to display all planar features as poles rather than great circles, but it's as simple as toggling it across to change that display. And also all points can be turned off or on by simply toggling the button at the bottom of the data pane. So we'll turn all the points back on in this particular case. If you inadvertently pick a point that does not represent a bedding plane, so in this particular case suppose we were to measure on that on this location, which is clearly not a bedding plane. We've reported an orientation. That orientation is clearly not correct. At this stage, the only process to remove that point is to click on the point in the data table, or to click on the point in the window, and then to hit delete at the bottom of the data table, and the point will be removed from the model, from the data table, and also from the StereoNet. Okay, so measurement of the orientation of surface features on the model is very simple. So to remind you, simply shift click or double click on locations and those points are entered. If you measure in complex environments, it's very useful to zoom right up and check that you have measured the feature that you expect to be measuring. Okay, so that was measuring surface facets of the model as planes. We can also measure other features on the surface of the model. If we wish to measure linear features, so in this particular case we might measure fold axes. So now we can turn this to measuring lineations, and note that this is context sensitive. As I turn the sample mode to lineation, the feature type assumes different values. So now for lineations there are a number of different types of lineations that we could measure. In this particular case we'll measure a fold axis. So if I zoom up on the model slightly, this edge here clearly represents a fold axis, as is clear when you look down the profile plane of at the profile plane of the fold. So the process of digitizing a lineation is practically as simple as it is to digitize an individual plane. However, we require 2 points. So again, hold the shift key down, click at one location, hold the shift key down at another location and click again, and the lineation is plotted on the model and also plotted on the StereoNet as a lineation, in this case according with the orientation of the bedding planes. Note that you do not have to click the points in any order. We can click points in either order, and GeoVis3D will automatically work out the plunge direction. So we'll do that process again on another plunging fold hinge here. So this time I will deliberately digitize them in the opposite order. So shift click there, shift click again, and GeoVis has automatically worked out that the line is plunging to the east in this particular case. Okay, so that's measuring lineations, a very simple process on the surface of the model. But other features that we might want to plot on the model include features that intersect the model. So in this particular case, an obvious feature that intersects the model would be the fold axial plane, and the fold axial plane designated across this surface here. If we wish to digitize features that intersect the model, then the sample mode is set to best fit plane. And in this particular case, we'll call it an other, because at this stage we don't have a distinct class for fold axial plane. Probably should have, but will in the future, but we'll switch it to other in this case. The process then of digitizing a fold axial plane involves clicking on locations in the model, and after 3 or more points have been digitized, GeoVis3D will automatically fit a plane to those points. So let's go through that process now with this fold axial plane. So I'll pick successive peaks on the anti-formal structures visible. Shift click on these locations, little green dots will appear. Notice if I do 3 points on a planar surface, GeoVis3D fits a plane, but the plane is shown in a red color or an orange color or a yellow color, depending upon the degree of collinearity and the degree of fit of the data. So clearly, if points are collinear, it's not possible to specify a unique plane. In this particular case, we need to add additional points around the surface of the model, and so if I add another point there, the plane now turns green to designate that the fit is a good fit, and also that the points are no longer collinear. And we could carry that process a bit further and digitize another point down here. If for some reason during the process of digitization you've digitized a bad point, Holding the Control key down and left clicking will remove the previous point. So digitizing intersecting features is as simple as clicking on a series of points that map out the feature. Note that it's only possible to uniquely define the orientation of a feature if the points are not collinear. Once you've digitized all the points and you're happy with the plane that you've created, to finalize your selection, press Finish down in the bottom right hand corner. That plane is now designated in the appropriate color for the category Other, and the pole to that plane is plotted on the StereoNet. Let's go through the process then of digitizing another plane on this model. So I will pick the adjacent synformal structure and pick a series of points. So shift click, again we'll pick that point just there, shift click. The plane is initially designated as red to show that it is both potentially a poor fit and or that it's collinear. In this particular case, the points are very collinear. However, to fix that process, we need only to designate at least one more point, which is on the fold axial plane but non-collinear with the other 3 points. Clicking on that point has turned the plane to be green, which indicates that it's both a good fit and that the plane is defined by points which are not collinear. Click Finish to register that, and again a new point has been plotted on the StereoNet. Note also that the features in the data table are color-coded to be the same as those features in the StereoNet and also within the model pane. So green features a lineation, and again if I click on that lineation it places it in the center of the viewport, it highlights it in the StereoNet and also highlights it in the data table. So all 3 views are linked. In the next short video we'll look at other features of GeoVis3D, including text annotation and drawing features on the surface of the model. We'll also examine how we can save sessions and export data such that it can be used in external processes.